This one here is C10H14O. It would have 4 double bond equivalents. We have a 5H in the aromatic region, and so that would be C6H5. We have CH2, 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 so we have 3 CH2 groups. And we have a 3H, that's going to be a CH3. What have we got left over? We've just got one oxygen. And there's our pieces. Now putting them together, we can get a lot of information by looking at the multiplicities, especially in the CH2 groups. What we can see here is we have a CH2 that's got 3 peaks, which indicates it's next to another CH2. This CH2 is quite interesting because it's got 5 peaks, indicating it's next to 4 hydrogens. That would be indicative of a CH2 between 2 CH2 groups. So that would be this one here. And that one would have 5 peaks. This one is going to be 3 peaks, and it's going to have 2 hydrogens next to it, so there'll be a CH2 next to a CH2. So we can be pretty sure, actually we can be absolutely sure, that the 3 CH2 groups are going to be adjacent to each other. Now we've got the oxygen and the CH3 to place in here, and what we can do is we can look around the 4 ppm region. According to the correlation chart, when you've got things that are around 4 ppm, that generally indicates their CH is connected to oxygens. And what we have here is a CH2 and a CH3, both in the 4 ppm region, indicating that they're both connected to oxygen. So my thought would be that the CH2 and the CH3 would both be connected to the O. We can get another clue here as to the placement of the oxygen by looking at the splitting we see in the aromatic region. If you have an alkyl group attached to an aromatic ring, that generally results in a single peak unsplit in the aromatic region. Whereas if we have an oxygen directly connected to the aromatic ring, it tends to split the ring into 2 peaks, and it'll be centered at around 7 ppm. In our case here, we've got an aromatic ring that is not split into 2 separate groups of peaks. We've just got the 1 peak grouping here, which indicates that it is probably connected to a C group, an alkyl group. So this should be our structure.